Hello everyone, welcome to this video. In this video we shall be solving question 27 from exercise 9.3. So here the question says we need to find what is the value of this n is the exponent here, such that this expression represents the geometric mean between the numbers a and b. Now this question is not as straightforward as other questions because here many power manipulations are required to be done. Let's see how. We know if two numbers are given to us, then their mean is given by square root of AB, correct? So that means both of these quantities, they are the same, we can equate them. And now we have to solve this expression in order to determine what is the value of n. So let's move forward and solve this one. So here you see we can take this term to the right hand side so that we would have the left hand side as such. And we can write the square root of AB as a raised to power 1 by 2, b raised to power 1 by 2, correct? Now what we can do? We can just multiply the terms inside. So this term would become a raised to power n plus 1 by 2, b as such. And next multiplication of this with this becomes a as such, b raised to power n plus 1 by 2, correct? Okay, now what we can do? We have this term here, we can shift this term to the left hand side and we can shift this term to the right hand side, so that we would have this term as such, this term here, this term here and this term here, correct? Okay, next you see you can write this 1 as plus 1 by 2 and plus 1 by 2. You will see in a moment why we are doing this. Here also you can write this plus 1 as plus 1 by 2 and plus 1 by 2. Correct? Next, doing so, you have, you can again split this term. You can write this as a raised to power n plus 1 by 2 and multiplied with a raised to power 1 by 2. Similarly, you can split this term b raised to power n plus 1 by 2 into b raised to power 1 by 2. Now you see in the expression that we have obtained, this term a raised to power n plus 1 by 2 and a raised to power n plus 1 by 2 is common. So you can take it as common. You are left with this term minus this term, correct? And similarly here, this term and this term, they are common in both the terms, so you can take it as outside the bracket. So you will be left with a raised to power 1 by 2 minus b raised to power 1 by 2. So you see this a raised to power 1 by 2 minus b raised to power 1 by 2 is appearing on both the sides and they are not equal to each other. Hence we can cancel these terms. So we are left with a raised to power n plus 1 by 2 is equal to b raised to power n plus 1 by 2. So we can shift, because the powers are same, we can shift this like this, a raised to power n plus 1 by 2 divided by b raised to power n plus 1 by 2, that is equal to 1. Now because the exponents are same, we can club them, so that we would have a divided by b raised to power n plus 1 by 2 is equal to 1. And you know, taking power 0 of anything, that is equal to 1. Hence we can write 1 as a divided by b raised to power 0. Now because on both sides of the equation the bases are same, we can equate the exponents, correct? So n plus 1 by 2 would be equal to 0. From here we can very easily compute the value of n, which comes out to be minus 1 by 2. Hence the value of n comes out to be minus 1 by 2 when this term represents the geometric mean of the two numbers a and b, right? So I hope you understood this question well. Well, that is it for this video. Thank you for watching.